Paul Spears, and I have a company called Stand Structural Engineering because we make things stand. And so the topic tonight is going to be on the RISA Revit link. And I don't know, how many people use RISA software? I'm just curious who uses. Okay, so pretty much everybody uses some RISA software. Everybody use Floor and 3D? Maybe does anybody use Foundation and those other ones, anything like that? Okay, all right, so some people use a bunch of stuff. So we'll primarily be focusing on the RISA Floor and RISA 3D link, but as you probably all know, I don't know how many people are structural engineers, but you can connect between all those other pieces of software as well. So there's a little bit of a presentation portion here, and then we will try to do some demos, and hopefully that goes well. I tried to go through the demos a few times, and it seemed to be working fine, but sometimes when you're trying to demo a process, it can crash on you, so we'll see how this works. So, you guys, there we go, okay. So, as I said, this is the RISA Revit link, and I'm with Stand Structural Engineering. So, the overview, the overarching concept that we're going to be talking about is essentially we're trying to reduce data handling, right? Whereby, the traditional process is, at least where I've worked, you have your CAD folks or Revit folks making a model. You also are making a model in RISA, and then you load that up. You print out all the results, or maybe you mark up the results on a set of plans and have the techs pick that up. And then you got to check it to make sure that it was interpreted properly, as well as everything matches. And so that ends up taking a lot of time. So if you can reduce the amount of data handling that you're doing, then ideally you can eliminate some errors, as well as speed things along. And so that's kind of the overarching concept of what we're trying to do here, or talk about, is reducing data handling. And then another thing we're going to be talking about is looking at extracting, is about how you're going to extract model data from Revit and then be able to perform structural analysis on that. So that will be kind of another thing we're going to be talking about. And then I wanted to talk a little bit about some of the other structural analysis options that are out there, and some of the tools that they have for translating between Revit and whatever that analysis software is, because there's other options out there. And I mean, I imagine all of you guys, if you're designers or engineers, RISA does some things really well, and it doesn't do some things as well. And so you sort of come up with a hacked version where you extract, you take the things that RISA does well and use that, and then you come up with your spreadsheets or whatever it is that you want to do. I mean, the example that I would give is concrete design. RISA's pretty good at concrete design, but I think that probably there's other software that's a little better at it. Previous places I worked, we basically just do it all with Excel spreadsheets. We actually had written things to whereby you could extract the RISA forces and data, but then we would run our own batch routines to come up with our reinforcing layouts and things like that. So, and then talk a little bit about the RISA products. And then we're going to try to do 3 examples of going back and forth between RISA and Revit. And hopefully they work right. I like to include this slide in almost every Revit presentation I do. And why I like it is so it says nearly half of BIM beginners are negative or break even on their return on investment. And then conversely, 43% of BIM experts claim high return on investment. So I hear lots of people will say, well, not so good. So I talked to some folks, and they're like, oh yeah, we hate Revit. We lose money on every project we do it on. And I'm thinking, I don't understand that. What the heck are you doing? Because it's so much faster to create a set of drawings in Revit than it is in anything else. And so I guess I am a big proponent that it is important for everyone, engineers and techs alike, to be experts at Revit, because it is so powerful. It's so easy to, once you get in and kind of figure it out, it's really easy to lay things out. You're halfway done with the drawings if an engineer models it itself or models something themselves, and then it's just finishing the drawings from there. So anyway, I'm a very big proponent that engineers should be experts in Revit. And I guess if anybody has any comments or questions, or if you want to try to break the RISA Revit link in some way, shape, or form, or know of some way that you've broken it, we can try to recreate that along the way. So the next few slides are some slides from a presentation that I done about leveraging BIM and the data in your models. And the main thing that I wanted to use these slides for is this whole add-in that we created for concrete beam schedules. I mentioned RISA, in my opinion, it does okay with concrete design, but it's not the best potentially. And so this is when I was at HNTB, we did these parking garages for Charlotte Douglas International Airport, and they were huge and had tons and tons of post-tension beam design. And so no one liked, we had ADAPT, which is another, it does post-tension design pretty well, but there were things that we didn't like about that. So RISA kind of does it, ADAPT kind of does it, but none of them gave us exactly what we wanted. And so consequently, we created a hybrid process, and I think this is something that everybody will probably have to do to some extent, is you create a sort of hybrid process whereby you say, well, we like what this does, how can we get this data from RISA to something else, and then get that something else into Revit, and once again, minimize the data handling. So what we did is we wrote this add-in, and we already had these spreadsheets that had been established. And so the key is that we needed there were certain pieces of information that we needed to map into Revit. So this add-in that we created, essentially you pick the data that you wanted to sync, which was rebar spacing, top and bottom quantities, post-tension bars, stirrup spacings, and things like this. And we already had our schedule set up the way that we wanted it to show. And then we linked that from our RISA analysis that was done and in the spreadsheets, and then had that right back into our Revit model. So this is an example of the spreadsheets that we created. There's a lot of information in there in terms of calculations that are being done. And then this is an example of the spreadsheet. And you don't need to get into, I guess, all of the, let's see here, I can't, oh, there we go. You don't need to get into all the stuff that's going on here. The point is, this is a shot of the schedule in Revit that has none of the data filled out, and this is a shot of the schedule in Revit after we've run our Excel reader. So one thing that was really nice about this, and was a sort of unintended consequence, is that the building was broken up into 6 quadrants or 6 chunks that were all separated by expansion joints. So each engineer could actually be working on their own chunk and then run independently this update, and you could be everybody working independently and then update, not simultaneously, incrementally, and get this stuff updated. So the problem that we run into was when something changed, and there always were things that changed. You were scrambling at midnight trying to go through and mark up all the beam schedules. And so what this did is they would just run their new batches, stuff would be updated, you just run the updater, and now you were done in 30 seconds. So here are some options that we all have, I guess, and I put the links up there if anybody wanted to, and probably most of you guys know about these. This presentation's on RISA, of course, but then the other big one is ETABS or SAP 2000. Both of those have a way of translating your analysis data between RISA and Revit, and their product is called CSI-X, I think is what it's called. And then they also have something that's unique to SAP is an API. I don't know if you guys know about API, but API is an application program interface. So if a program has that, it allows you to write your own sort of translation, and you can a lot of times run the program without having without manual input. So you could write translators essentially to go between SAP and ETABS. And in fact, one of the things I'm going to show here is there's if you guys are familiar with Dynamo, the folks at Thornton Tomasetti Core Studio has written a module that goes into Dynamo that lets you modify SAP models with Dynamo, which is pretty sweet. RAM is another one, and they have the RAM structural system, and it has a lot of the same functionality as RISA. I honestly haven't used RAM in a long time. I used it probably 10 years ago, but and I imagine it's a fine piece of software. Now, I did read up on this, that apparently they no longer, as of 2014, they don't support a direct link between Revit and RAM structural system, and instead they have something called an iModel, which you can publish your Revit model to an iModel, and then that iModel can be consumed by RAM structural system, and I believe then you can go back to an iModel with your design and then back into Revit. I think that's the way that it works. Does anybody have any knowledge of that?
That sounds about right. I'm kind of familiar with it.
Okay, you are, okay.
iModel is kind of the equal format they use to pass out the data in format.
Yeah. So then you have Revit structural analysis, and I think these are some pictures from, this is a picture from the Revit structural analysis. I have messed around with this a little bit, but found it to be really cumbersome and slow. I imagine if they stick with it, it will get better, but as of right now, I don't think this is a very viable option. Does anybody else have any experience with that to say, no, you're totally wrong, it's awesome? No, okay. Skia is another one. So that's an analysis package, and I have heard their presentation a couple of times, and it is my opinion of Skia that they are primarily a European company trying to find some American guinea pigs who would be willing to try their product, because they didn't have any of the American codes in their software when I talked to them last. I'm like, why would I use your software if you... So anyway, but I mean, from the presentations they give, it looks like a pretty powerful piece of software in terms of being able to model things. They use to translate between BIM products, they use something called Open BIM, which I believe is more of a European thing anyway. I think in Europe, Open BIM is a bigger deal. And then there's Tekla. And I don't know if you guys use Tekla or not, but Tekla certainly is what steel detailers use. But they have a structural analysis package that you can get from that too.
Hey Paul, is this Revit structural analysis the same thing as robot?
No. Revit structural analysis is actually an Autodesk 360 cloud design option where you upload your Revit model or some exported version of that to the cloud in A360. It does whatever analysis it's going to do and then pulls it back into Revit. And I believe that somehow through the add-in that they have, it does things like shows your deflections and stresses and things like that in the model. But like I said, it was really, I found it to be pretty cumbersome.
Have you used robot at all?
I have only opened Robot briefly, only to think that it felt pretty cumbersome too.
I think they have European codes as well.
Yeah, and it's weird because like when I opened it up and tried to do anything in it, it was not intuitive at all, and I could not comprehend how you could actually do anything complicated. And then I see somebody say, "Does anybody know how to do nonlinear dynamic analysis in Robot?" And I'm like, well, I don't know how you would do it. Apparently you can, but but you know, it's, the other interesting thing is, like every couple of years, you almost have to reevaluate every piece of software because they do so much with them and they change things and add things. And one piece of software that was awful becomes awesome all of a sudden. And so
I know we had a consultant. Sorry, had a consultant in just yesterday, and he was asking me, "Are you using robot?"
yeah.
Like, no.
Yeah, no one's using robot.
No.
I don't know anybody that uses robot. Does anybody know anybody else that actually uses robot? Yeah, I don't think anybody uses robot. Maybe Europe, I don't know.
Yeah, right.
Okay, and I guess I already kind of talked about the options for translation. Now, The one thing I did not talk about is this this Dynamo option, and I only bring this up because I think Dynamo is going to be a pretty powerful tool in the future, potentially for all of us to be doing all kinds of stuff with our Revit models, and I think maybe even that involves some analysis, either translating between RISA or SAP, and the other one that I have up there, and I put TT up there. So Thornton Tomasetti, I don't know if you're familiar with their Core Studios folks. They have some really cool stuff that they're doing with. You should go look at Core Studios and look at some of their YouTube stuff that they've done with either Grasshopper or Dynamo. It's really awesome stuff. And the one thing that I wanted to bring up here, so this is TTX, which is something it's not available to the public, but it's something I think probably where the industry needs to go, and it's probably like that iModel thing where. So Thornton Tomasetti has this TTX product that essentially it maps the members in their model to members in SAP models or RAM. So essentially, it's this problem that I was kind of talking about where each piece of software seems to do something pretty well, but maybe is weak in other areas. So if you literally had some piece of software that could translate and let you use, say, RAM structural system for concrete and SAP for steel design, and then take it to Tekla to do some detailing, but then go back to Revit for your construction documents. If you had the ability to have something consolidate and make sure that those things stayed consistent, then that's pretty powerful. So, and this is not available to the public. I just bring it up because in my opinion, this is kind of where the industry should go. And I did want to show. We'll see if this actually works. There we go. Okay. So this is a YouTube video of this Dynamo to SAP. Let's see if this works. So Dynamo, essentially it's a interface where you put all these sliders and junk in there, and then you connect it to other modules, and this is a SAP model that they're driving with those sliders and things like that. And they dump it into SAP, run some analysis. I think it's able to pull back in the analysis. You're seeing it in Dynamo. You get to see the forces. Anyway, I think it's pretty cool. Let's see here. Okay, so now moving on to the RISA Revit link. So this is their little graphic that they kind of published that shows you being able to do your RISA analysis and go back to Revit and do your round tripping. That's what everybody says is the round tripping. And as I mentioned, if you're not familiar with RISA products, kind of 3D is, I guess, what I would call their core piece of software. And then they have various modules that sort of tie into that. They eventually came up with RISA Floor, which is primarily for doing floor designs and composite beams. They have RISA Connection. I don't know if does anybody use RISA Connection? You guys have used that? So that seems like, I demoed that again recently. It seems like it's getting more powerful. The bracing connections don't seem like they're quite where they should be, but
it's good for shear connections, basically.
Yeah. Well, so the interesting thing is, I don't know if you guys are the same way, but we always just had connection tables to handle that. So it's kind of like, I don't need the shear connection, I need the bracing connections. And
yeah, we don't, so this is good for us.
yeah, okay. Then they have RISA Foundation. They also have RISA Footing. RISA Footing is kind of I don't know, it doesn't do nearly as much as RISA Foundation. RISA Foundation is a pretty cool piece of software for doing foundation design and complicated foundations. This section for built-up shapes and section editors and things like that. And then they have RISA 2D. Then I put the little graphic for the time history analysis that they just added that, and they came out with that maybe a couple weeks ago. I haven't had a chance to mess around with it too much, but I'm pretty excited about that for doing both some vibration analysis stuff as well as seismic stuff. So, okay, so this is from a previous presentation as well, and I guess what I'm going to say about this is that the intent of this slide is, so when the process that I mentioned before early on of like you print out you build your RISA model, you build your Revit model independently, you print out the results, you hand it to a tech, they pick up your marks, you got to back check it and make sure it matches. And so I have heard people say it takes too long to learn, say, the RISA Revit link, or they're under the gun and they start messing with it and they're like, I can't get this to work, and so they just punt and they go back and sort of go back to the old method. And I guess what I would say is, let's say someone spent 30 hours on a project trying to figure out how to get RISA and the RISA Revit link to work and get stuff to go back and forth properly. And so you say, well, wow, you really just blew the budget on that project. We didn't have 30 hours to spend on that. And I guess my contention would be is, yes, you probably will blow the budget on the first one you do of when you're trying to learn it. And you might even tweak your process every once in a while. But I pulled 2 projects, and these were from projects that we did at HNTB, and pulled the number of beams and braces and columns, and just guessed on there of time to update. So a beam, maybe it's 30 seconds to change the size, put the studs on it, put the camber on it. Maybe that's, and I guess the point there is, even if I'm off by a factor of 2, and it only took you 15 hours, that still is a lot of time to update all the braces, the columns, and the beams. So can you afford to spend 15 hours learning the RISA Revit link, and then, yes, it was painful to do that, but now you've got that knowledge in your tool kit to where that you can go to your next project and it takes you 30 seconds next time to go back and forth between RISA and Revit. Or you're modeling it and you say, well, I already know that it's going to break in these ways, so I'm going to fake it in these ways, and when I come back, then I'll just mark up those 6 beams by hand, something like that. So anyway, point is, yes, it does take some time to probably work the kinks out of this workflow to kind of share data between these pieces of software, but I think in the end it pays for itself. So we'll see here if I can get some of these models to work right. And I'm gonna show 3 examples, and each one of them I'm going to show a couple of things on them. So this is a quick model that I created. Well, let's see if I have this in here right in terms of, I wanted to make sure under my structural framing. Okay, so I only have a few beams loaded in here right now. So this was just a stock Revit file that I started with, but I wanted to show, and I think I maybe will start a new one just to show some of the modeling things. So one of the reasons I would recommend that, say, engineers get involved in modeling Revit projects, the tools that are in Revit for doing complicated geometry. So you can't do radial grids in Revit. You can't do skewed grids in Revit. In RISA. Did I say RISA the last time too? I don't know. Revit. Sorry, you can do that in Revit. You cannot do that in RISA. I'm sorry. Unless someone correct me if I'm wrong, but I don't think you couldn't do it.
You can do radial.
In RISA? It'll do radial grids, or?
Yes.
Okay, what about skewed? Will it do skewed now?
I don't think so.
Not
Maybe
skewed.
you only do grids, but you could definitely make a grid with it, and you just can't call it the grid line.
Yes. You're saying you can create a radial snap points, right?
Yeah.
Yeah. All right, this is taking a little while here. All right, there we go. So one thing I would recommend is if you are learning Revit and wanting to do Revit, you definitely use quick keys. So my quick keys, I've overridden a bunch of my quick keys, so I do CC is create, or CC is copy, CS is create similar, MN is move. So I can navigate pretty quickly in creating some of these things. So the nice things here, I can create a radial grid, and RISA doesn't let me do that. I can actually also, if I'm doing, one of the nice things is I can do a segmented grid if I wanted it, and actually do something that was even pretty irregular, and it will allow me to do that. And then I can come in here and say I want to put columns in, and I want to say they're at grid, so I'm just going to window over all of these, and it automatically puts them in. So if I want them to align to the grid lines, I can just hit my space bar. This one's not aligned to the, so I'm going to delete that one and start over with that one, because if you come over here and mouse on it and hit your space bar, then it'll align to that grid. So like that's nicer in my opinion than how you would do it in RISA. There's just some things about the way that you model in Revit that in my opinion make it easier to do. So then I can put in beams, and I'll say I want those on grids, and just window over all those. So, whoops. So then I could export that to RISA if I want to. But I'm only showing that just to show, in my opinion, RISA or Revit is a nicer tool for modeling. So what I've done here is I have created this floor, and then tagged out all the beams, and you can see that all the beams are W12 by 26. Now, what I'm going to do is I'm going to run the RISA Revit link export, and actually I think what I'm going to do here is I'm going to save this. Put it in here. Okay, we're going to export to RISA. It's asking me where I want it to save the exchange file. I'm going to say I want to save it there, and I'm not going to launch the program. We're going to dump it to RISA Floor this time. Interestingly, there's this option of whether or not you want it to export physical model or analytical model, and I'm going to hit cancel here and go to a 3D view just to show the distinction here. So the black objects there are the physical model. The colored objects there are the analytical model and where those are located. So in this case, they are all aligned, and I'm going to, in another example, I'm going to show you, which is the R2, they are not aligned. So like in this case, you can see the analytical model is actually in this wall, not on this column. Now, and so technically what that option is showing there when I'm doing the export, and it says physical model or analytical model. The physical model should take where those black objects are and import those, and the analytical model should take those colored objects. However, it has been my experience that it always takes the analytical model, so I don't know if anyone has done this before and can confirm that they were able to get it to actually take the physical model. So I guess my point there would be you almost always need your analytical model to be how you want it to be before you export into Revit. So in this case, this one's a pretty easy model, and so you can see, everything's pretty much connected, and sending it over to RISA is it's a piece of cake. So I a lot of times won't take over the walls or the diaphragms. I rarely am dealing with those. Oh great, and it didn't save that. So I'm going to run this. It's going to go through and verify everything's okay, and then it's going to tell me, give me a list of, it exported 4 grid lines, 14 beams, 8 columns, 32 materials. The unfortunate thing, it would be nice, it exports all the materials in your Revit model, even if they're not used. It would be nice if it would actually export only the ones that are actually being used by by your RISA file. So now we'll go to RISA floor. Not sure why it took me a long time for Revit to open up as well. Anybody know a good joke while we're waiting on this?
I'm gonna try some of the lighting presets to see if we can get.
I don't know. Well, here we go. There we go. Got it. So you go to import Autodesk Exchange Revit file. We're going to navigate to where that was. Click open. Okay, so that brings all that in, and I believe I had it set there to import, to do a redesign. Let's see here. So optimize member sizes. So that means when I bring it over, it's not going to have any sizes in there. So if I go to shape. So this is common in RISA floor. Like when you first start drawing things, you don't have specific shapes in there, right? You only have, it says wide flange or channel. So like when I go to draw something, you know, it says this is the shape group. That's all it's going to show is wide flange. Or if it's wood, it'll show it's a rectangular. So I can change that to be, you know, single angle or something like that. But because I had this set to optimize member sizes, then it didn't actually find the the actual sizes. So which is fine. So in here I'm going to put in a deck. Oh, that's the other thing. It doesn't actually bring over a deck. So I got to put a deck in there, and we're going to call it a composite deck, and I'm accustomed to using Volcraft, so we'll go with that. Embrace length on our beams too. If you guys aren't familiar with this, just feel free to stop me and I can describe what I'm doing there. So it comes pre-loaded with some load combinations, but I'm going to add a pre-composite load combination, and we'll add in that pre-composite dead load and construction live load. We want to run those. We want to design hot rolled. I think you want the connection design so that it will actually take back over the reactions if you needed to do those. So we want to model in deck. No, we want it to be Z. Now we've got a deck on there. And let's see here. What else? Oh, we need a perimeter. We can run it. And I'm just going to say okay. All right. So now it gives us our design, and you can see here it's sized all of our beams for us, and gives us our reactions on the end. These numbers in parentheses are headed studs that are on the beams, and then it gives us camber underneath that. So we can, you know, normal process, or not the normal process, but you potentially would print this out and give it to a tech and have them pick it up. But now we can import that back into RISA. But let's say, back into Revit. Sorry, I keep saying the wrong thing there. All right, so let's say though, actually, what happened here is this beam is actually, while we were working, this beam moved on us. And actually, while we were working in RISA, we decided that we wanted to add another beam, and it goes composite, and it goes in here. So now we're going to run that. Hopefully I'll be able to illustrate this for you. Okay, so we got that redesigned. You know, it didn't pick up on this yet, but we moved that over. but it's got our new guy in there, so we've got this saved. I'm gonna go to Revit and I'm gonna say, no, not export. I want to import from RISA, and it's gonna ask me if I want to update geometry and sizes or if I want to update member sizes only. Now, one of the problems that I had heard from somebody is that it was in RISA they were moving things around, and then it would, and things in Revit were moving around, and then it would move those things in RISA to overwrite some of the stuff that had been done in Revit. And I think that there is a potential for that to happen. And so what you probably have to do is, if you know you're going to be moving some things in Revit that you want to show up in RISA, you do another export from Revit to RISA, and you can actually import that again, and it seems to remember that you did that, and then export that back to Revit from the design. So anyway, let's see here. I'm going to just do member sizes only, and let's see what this thing does. Save. See if that works now. Okay. And there's a couple of things I want to show. This one's not going to work, and I will. Okay, so what it tells me here is that it only modified 2 of the beams, and all the rest of them failed. So one nice thing about the RISA Revit link is that it shows me things that were updated, and the things in black were not changed, the things in yellow were changed, green members are members that were added. So the only 2 members that it was able to update were ones that were already loaded. So this is one of the issues, and I don't know if you guys have found this before, but let's say you wanted to reload, if I wanted to reload more shapes, so I click reload, and it actually doesn't know where to go to reload that wide flange. I don't know if you've experienced that before, but sometimes it seems like Revit knows where the file was, the family file was that you want to load, and sometimes it doesn't. So in this case, it didn't know where that family file was, so it just gave up in terms of trying to actually load the new types in. So one of the ways that I get around that is I will, a lot of times for my RISA Revit files, and it will make your file a little bit larger as you, and now I got to navigate to find this. Unfortunately, for some reason, my Revit 2015 library was lacking. It didn't have wide flanges for some reason, I don't know. Apparently they didn't think we needed to use those. So I'll load it from the 2014 version. And I will load in all the types that I think I might need. I don't think I have anything bigger than a 20, I don't think I even have any 24s in this one. I'll add those though. So I'll just come down here and I'll grab, I realize this is a lot of members to load, but so I'll load all those in. And there's also a deal in the RISA Revit link where it says don't import twice, and I was doing it and it didn't seem to have any problems. So I don't know if they fixed it or what the deal is, but see, it says the last time you already did an update and you shouldn't do this again. It'll create duplicate elements. And I did not have that problem, so I don't know what the deal is. So I'm going to run this again. Now you should see more of this yellow, that it's actually updating these beam sizes because I have all the types loaded. "14 modified," but it still can't find. In the RISA file, it had columns in there that were W4s and W6s, and I didn't go through the effort of actually loading in more columns. But you can see here, it was able to, and actually it did, did I do, so interestingly, even though it said update member sizes only, it also moved this, no, wait, take that back. We did not move it in here. Okay, so this beam got updated, but it potentially is in the wrong spot. So the loading on this beam and this beam is probably wrong from our analysis. So now we've updated this, and the right thing that we need to do here is probably go ahead and go, and I'm going to close out of this, and I'm going to go export to RISA again, and I don't know if I care if it optimizes or not, but do I want to do that? Let's see here. Oh, you know what? I actually don't want to do that yet because I think I might lose my extra beam. Well, let's do this. Let's try something here. I'll just save this out here. Just in case I lose my extra beam. I'm going to navigate to export to RISA. I'll let it optimize sizes. So now it should have this beam location updated. I don't know if it's going to keep that beam that's in there if I open this particular version of it. Because and that is something that I found is that when you have the checkbox checked to only import member sizes, it doesn't find new members. So you have to have the checkbox checked that you want to import geometry and member sizes in order for it to recognize new members going from RISA floor into Revit. So let's see, I'm going to go to the import again. So instead of opening that model, I'm going to go to import. And it seems to know that it needs to merge this new file with the existing file. Okay, so it moved that over. Okay, so this is actually, I think that's pretty impressive in my opinion that it actually knew to move this beam over, but it also kept this beam in there when we did that export. It knew to merge those two files. So now I can run the results again.
Now, is that partially because Revit has piece numbers for each beam?
Yeah,
Is it
so the
tracking
weird
some of
thing,
that?
I tried to open up the exchange file that they have. The weird thing is I can't figure out how they actually have it mapped right.
Okay.
Like, it
I don't know
doesn't-
if you deleted it and then put a new one and moved it, if it would.
Yeah, if you deleted it, it would not understand that it was new. Yeah, it would be confused, right? So if you're moving things, that's definitely different than if you're deleting things. So now, what I want to do here, I'm going to save this again, and in order for it to recognize this guy, when I come back in here and tell it to import, I'm going to go import from RISA. I need to select that I want update geometry and sizes, and I'm going to go OK. And now, I think this is all going to be black because it should be basically, well, these two might be different, but most of these other sizes should have been the same ones that it had from the previous analysis. And it still can't figure out what to do with the columns because I didn't add any more columns in there. I guess in testing this, okay, so now it's telling me it added one beam, modified 4 columns, and added 23 materials. Okay, so apparently that one stayed the same size. This one got updated. It must have found those this time? No.
It went from W6s to W10s when you reanalyzed it.
I wonder if it just used the size that I pulled from Revit. Okay. But anyway, it kind of gives you a nice color-coded view to show you what changed or what didn't change. So that's that. Any questions on this one? Oh, let's do this. Okay, so now our previous model we had, so it's got all of our tags have been updated, but now we had some new members or some redone members that did not get tagged. So I'm going to go here. I think I have to load in the RISA. Well, so we'll go through that process of tagging these. So RISA adds to your file. Let's see here. Let's see, scroll this down. All right, so out of the box, the parameters that are in your model is camber size and number of studs. So that's out of the box. But what is not out of the box is the reactions. So RISA has their own parameter that they add. That is RISA start reaction, RISA end reaction, and then if you have moment in there, then it will report that as well. And then it also puts this RISA label, and I think that actually probably helps it in terms of knowing if the member's been deleted or not. So I haven't gone in here and tried to see what would happen if you like gave 5 members that same Rev M1, if it would get confused and say, "What are you doing to me?" You know, and so I didn't check every permutation of how you could break this off. But so we don't have our reactions on here, and we want to do that. So let's look at, we want to add in studs and camber. So this is a different tag that has studs and camber. We want to have reactions on the end. And here, none of them are loaded. So, and it's in the RISA folder. So I got to go to C, I think it's in RISA. And then there's the, or not in there. Here. No. Thought it was in there. All right, so this is when I hunt on trying to find that, and I go. So this is one that I had, it's basically the same one, but I had already done it, and said I did. All right, now I got to find the RISA tags. Let's do this. When in doubt, insert C RISA Revit link. Oh, it's C RISA, not C program files. Okay, sorry about that. All right, so let's try this. C RISA. Theme tags. So I want to get, I don't think I need that one, but we'll go, I don't think we need these, but we might as well load them all in. Studs camera. So now when I go to annotate, I'm going to change the way that we're tagging these beams. I've got I don't want the standard, I want studs and camber. Tag with studs and camber. Then I want, RISA start reaction. I want RISA end reaction. I want to remove existing. I want to tag all of those. So now it puts all those on there. Now, I don't know, this is the default on how this works, and I don't like the way that looks, so I'm going to edit that. Label, and I'm going to say studs is in parentheses. Camber is going to be, I'll put that in a bracket and do C equals, and then a close bracket. Okay, so that was better. So then we can come in here, and if this stuff isn't in the right spot for you, you can kind of move stuff around as you want to move that. So there you have it. It's tagging all the reactions and any questions or comments on that? Or
Hey, Paul, on the color-coded 3D view,
uh-huh.
is that just a view filter that's applied, or can
I
that be
think
applied to other views?
No, so I think this is actually, so this is a view that RISA creates, like the RISA link creates this, and I believe they do it with overrides. So
Oh.
like it's not actually,
It's not a filter?
it's not a filter, it's just, so like I could come in here and go, so yeah, see it's all overrides.
What if you created a view template based on that view and applied it to another view, would it work?
I don't know.
No big deal, just curious if you applied that to a plan view and saw all that, if that'd be more useful.
I don't think that works because it might be overriding by the element ID.
Yeah,
So
Does that not
it
take
per
won't-
view, yeah.
You won't have the same element ID. It won't work.
now, what you could do, if you knew how to use Dynamo, would be probably something like select all members that have that color, or that in this view that are that color, and then select all members that are that color in another view, or create a selection set based on all these members. So I mean, I guess I could see where you could get there from. Let's see what I want to see what happens if I did duplicate with detailing. I mean, I suppose that you could, if you wanted to, and you had a multi-level building and you wanted to kind of look floor by floor. I mean, you could do slices of it,
Yeah, sure.
and then just do a top view of it or something, and kind of. I mean, it still wouldn't give you maybe exactly what you wanted, but
No, that gets pretty close.
yeah,
If you had an existing working view,
yeah.
sometimes it just apply that to it.
Yeah, so I guess that maybe you can't do dependent views of these, can you? No, you can't. So I guess what would happen if you, well, so maybe a downfall of that is I think it probably only updates that one view. So now all
Sure.
those other views that you just duplicated didn't actually copy the new.
True.
Yeah, so that probably doesn't work. Never mind. So there's that one. Now the next one is kind of getting more into, if nobody has any questions on that one, I guess I'm going longer than an hour almost here. Let's see here, we'll go to this structural plan. Okay, so the thing that I want to emphasize is the importance of the analytical model and sort of some of the things that RISA does or that happens within Revit that makes it not correct. Okay, so one thing I would recommend, first one I want to talk about is it seems that the analytical model wants to go, okay, so I'm going to select this, and I need to select the analytical column. Okay, let's try this. Okay, the properties in this analytical column is it says, what's your alignment method for the top and the bottom? And the default is auto detect. So what that means is my column is actually here, but what it thinks is that I have this wall out here. It thinks that it wants it to be in the corner of the wall. So it automatically moved it to that corner, which is not correct because now I've got this skewed beam going over here to this weird location. And this wall is technically maybe only, it's a non-load bearing partition wall. I didn't want it to go to that anyway. And so, and the problem is that when I export this to RISA, that goes with it and it goes to that weird location. It's not on a grid. And so you get the same thing happening over here where it pulled that analytical line over into that wall. So to deal with that, what you can do is change all of these to be, in your analytical model, change those to, instead of auto detect, change it to be projection, and base alignment to be projection. Okay, so now that moves it back to the center line of the column. And now you can see this is in the right location, but it still is in the wrong location for that column. So I can correct that by selecting that one. And so what you can do here is you can select all of these, potentially select all your columns, structural columns, and I'm going to change those to be, wait a minute, that's not what I wanted. I did the same thing, didn't I?
You did the analytical column.
I'm not used to selecting analytical. So I'm gonna change the alignment to projection. I think it did it. So if I scroll in here, and then all of those should be now going to the center line of those columns. So I guess my opinion, or my recommendation would be is that, you know, from the get-go, you might want to just change all of your projections to be center line of the column. Now, one reason why you might not want to do that is, let's say you had a concrete building where the beams were all aligned to the outside face, and your columns actually projected in. Maybe in that situation, you don't want that to, you do want that, the center line of that beam to actually be out further, kind of in line with your beams, rather than moved in with your columns. So, and then here, what I wanted to show is a couple of different situations with these beams. What I had done here, I think I rotated the axis of one of these. Which one was it? It's this one. Okay, so this one, you can see I rotated the axis on this one. And we're getting kind of low on time here, so I won't demonstrate this, but this will translate with the rotated axis into RISA 3D, but RISA Floor can't handle rotated members. It can only do 0 and 90. So you can rotate it, but it has to be 0 or 90. It can't be at some strange angle. So I don't know if you ever need a strange angle, you probably have to go straight to RISA 3D to do that. And then the other ones that I was going to show here is I did on this one. So the member in this case, I did an offset on it where I did a Y justification left. And that's not necessarily what you would probably do. Actually, I want it to be center. So now it's back on the column. So you can see that moves with it. If you did a left justification, then it's going to it moves that analytical line with it. So you need to kind of pay attention to that. One thing too, I did an offset here. If you do start level offsets, and I don't know how much you guys have messed with this, versus doing a Y or a Z justification offset, it pulls the analytical model object down when you do an end offset versus, or a level offset versus a Z justification offset. So in this case, I did a Z justification offset of a foot, and it did not pull that down. Now I can make it go down to it, I believe. See if I can get it to select. So I select this beam, and so it's set to auto detect, and I'm going to say projection and projection. I think it's actually not going to go down yet, and so I have to say I want my Z projection to be top of element, and my Z projection to be top of element. So now it goes down. So the point is, you kind of got to mess with this and understand what that analytical model is doing and the relationship to your physical model. And then when you dump that over into Revit, that's going to go over. And the thing that I want to show here is, so this was already loaded in HSS Brace. And so I'm going to save this, and I'm going to load it into RISA Floor. I'm going to close out of this. We're going to go, oops. I'm going to go to RISA 3D this time. I don't care about the project grids. Oh, I don't know. See, it only lets you do analytical model when you do RISA 3D in there, or go to RISA 3D. Okay, so we're going to export again. Export those things. We'll go to RISA 3D this time.
Oh, great.
Let's try to cancel that. We'll just launch it as a demo. Okay, so you can see it pulled everything in. I didn't show, but like if this would have been that model that I had previously, these columns would be off those grid lines and things would not be lining up right. They wouldn't be connected. And in fact, I had a problem even when I pulled this in where it didn't even recognize that there was a connection between those two when I didn't have it set to be at that projection line. When it was set to auto detect, it screwed a bunch of stuff up. Now, one of the things that I want to point out here is RISA is confused. It thinks when it can't find a shape, it calls it it puts a 1x1 rod in there basically, just to have something in there. And so the problem that we run into, you look in the model and you say, well, the HSS 6x6x half, that seems like something that it ought to be able to find. But the problem comes in the mapping file. So the way that things get from RISA into Revit is through a mapping file, and that is found in the folder. And so I have it open here, and so if I scroll down and I find my HSS 6x6x half, so this is what it's called in RISA. This is what Revit is expecting it to be called, is 6x6x1/2 for half, not 005. So consequently, if I am going to use that particular family that's named that way, I have to add more lines to this mapping file in order for it to get it to read that into Revit or into RISA correctly. So another one, and this is probably even more critical or crucial, is dealing with bar joists. So bar joists, when you have point loads on them, RISA will design them and call them SP joists, which they should be, but there's no such thing as an SP joist in Revit. So when you try to read it back in, it's going to be incorrect in finding that joist size. So you either, one of two things, have to create a mapping system in here where maybe if you have SP joists, then it drops the SP and you just tell it that it's a K, let's say it's a 16K3 or something. So if it's a 16K3 SP, you just tell it the RISA, if the RISA shape is 16K3 SP, then the Revit shape is just 16K3. Then you have to remember that you need to add an SP or something in there to identify that it's a special joist. Otherwise, you could create a whole other set of types of SP joists in your Revit file, and then map them that way. So that I guess is the one thing I wanted to point out there, is that sometimes you will have mapping problems, and it's because it doesn't exist, or the naming's off a little bit. So the third one, we're out of time here. The third one was essentially showing concrete. And so it seems to be able to create new types in concrete. So with steel, if it can't find the type that's there, a W8x10, then it just gives up and says, I couldn't find it, and it doesn't change it. Whereas with the concrete, it seems to actually create new types with those new depths and widths. What it doesn't bring over is any of the reinforcing or the stirrups or anything like that. So consequently, concrete is a little bit limited in what you can bring over, and so then you start having to do something like what we did with that add-in, where you have a spreadsheet or something like that that can read that data and dump it into parameters or however you want to show it. So and I did a little bit of research to see if there was any software out there that actually could do concrete design and bring the data in, and I couldn't find any. I don't know if anybody knows of any that will actually bring in rebar.
I know Techla's got some stuff in their new programs that do a lot with concrete and rebar design.
Will it pull it into Revit?
I don't know, I haven't played with it, but I've seen
Yeah.
kind of creepers with what it looked like about 3 or 4 months
Yeah.
ago.
So anyway, that's what I have. Any comments or questions? Or
Have you so you've done joists?
I have done joists.
So how do you handle the joist seat? And if it's a long
I ignore
explanation,
Wait, what's?
If it's a long explanation we can talk about later. You just ignore it though?
Yeah, I have everything modeled at the top. You're saying there's an offset.
Right, it's we've struggled with getting the offset fixed. Like, we've gotten the analytical model and like pulled the nodes up and everything,
Uh-huh.
but the nodes for us haven't locked or any, like, found a,
So one thing you could do, so let's say we had this in here, and I think this is probably a decent one to do this with. So I'm going to select all these beams in here, and I'm going to say, I want analytical beams, and maybe this isn't addressing what you're wanting to do, but I'm going to say I want my alignment method to be projection, and I want my Z to be at level 2. I want this to be projection, and I want my Z to be at level 2. So now it brings all those up to the same elevation. And now ideally that would take care of the problem that you were having maybe?
yeah, well, I guess the other issue is it'll be, like, a roofs will be sloped. Will that still solve that problem?
So let's see here.
You wouldn't be able to set it to level 2.
Right. I mean, that's where we break it every time.
Can you
is
set
that-
it to
I mean,
a
maybe the grid lines are
work plane
at
or?
certain elevations, so we can set those, but then you'll have like a joist that lands in between two columns that's
How do
a
you,
random dimension that you.
okay, so I have an add-in that I wrote that I like. I can see if you like it, you can try it, but essentially what it does, so one of the things with sloped roofs, I don't know what you've normally done, but there's a deal where you can say, I want it to lock to the underside of a floor system. So you slope the floor, and then all your stuff you model is actually locked to the underside of that floor.
Okay.
Now, the problem with that is that everything rotates to be aligned with that. So now all your girders are rotated at 1/4 of an inch per foot slope, and that, in my opinion, doesn't solve your problem. So I wrote an add-in where if you have a slope on a, you model your roof as a floor. I don't know if I have it in this one, but, and then you can run this add-in that essentially says, change your member offsets, your start level offsets to be the underside of the roof. So it will change all of those to align. So anything along that roof will update to that line. And there's an option in there that says, do you want an additional offset? So you can do 2.5, or is it 5.5 for the, or something custom. So you could select kind of all your girders and put those down 2.5, and then all the rest of them are up at the. So then I don't know if it would give you the option here for your analytical model to do. Let's see here. Oh yeah, so let's select one of these things. So a level, bottom level location line. That might have problems. So the one thing that you can do there too would be you could say location line, and then with all your girders you could do a Z offset. So the Z offset seems to, like you can see here, well I told those to all go to. The Z offset seems to move the member down but doesn't actually change the analytical location of it. I guess I could do one real quick. Let's see here, let's see if I get a... Are there any other questions I can, or comments, or?
While he's working on that, if anybody, make sure you sign the sign-in sheet. And then if you're new to the group, it's your first time here, start your name and make sure your email address is there so we can, or if you want to receive future invitations to these meetings, know what's going on in the team.
I don't know if I have Beam first. I think I don't have any. So I don't know if you guys have noticed this either, but so in my experience, the distance between panel points on trusses, open web joists, is 2 feet, but that's not the way the Revit family is set up. So I've gone in and changed the one that I use usually, but I don't know, it's interesting to me, sometimes I feel like the people that made Revit Structure didn't know structural engineering. Where's my K-joist? Not even in there? Unbelievable, another one of the ones that wasn't in the... Oh. Okay. Just pull it from 2014. I'm just gonna put in a beam system and,
Beam system doesn't have any effect on the recent, does
no, it works fine, at least in my experience, it works fine. I guess I didn't test, like if you moved things around in that beam system, if that breaks it. I would guess that it does because it's a pinned member, but it doesn't seem to affect it when you're updating members and reactions and things like that. It seems to come over fine. I'll do 4 feet, I don't know how big that bay is. Okay, so let's do let's say there's a slope on, I think it's actually gonna go up by itself if I just say that there's a slope on this of 1 foot and 1 foot. Yeah, I think it's gonna take that up and then go ahead and make, oh good, I got, is that a 2? Yeah, that's what you want, 2, right? I'm gonna take that up 1 foot too. Okay, so that's following that line. Now the easiest thing here I think is probably if I just select those and do a Z justification offset of minus 2.5 inches. I believe that's going to go down and not actually affect. Let's turn off the analytical model. You can see that actually, is that, I forget who, oh yeah, so that, is that maybe address what you're having an issue with, or?
I think so. Is that how you would bottom joist them?
Yeah.
Yep.
Now, what? Yeah, so we had all the analytical still lined up on that then, right?
Yeah, the analytical stayed lined up because in that situation, when you do a Z offset, it keeps the analytical line up at the top.
Right, right.
Thanks.
That's it, maybe? Anybody else? Okay, thanks for coming.
Thank you.